Hello and welcome to another episode of Twiml Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. Thanks so much to those of you who participated in the Twiml online meetup last week, and to Kevin T. from SIGOPT for presenting. You can find the slides for Kevin's presentation in the meetup Slack channel, as well as in this week's show notes. Our final meetup of the year will be held on Wednesday, December 13th. Bring your thoughts on the top machine learning and AI stories of 2017 for our discussion segment. For our main presentation, prior Twiml Talk guest Bruno Gonçalves will be discussing the paper Understanding Deep Learning Requires Rethinking Generalization by Xiyuan Zhang from MIT and Google Brain and others. You can find more details and register at twimlai.com/meetup. If you receive my newsletter, you already know this, but Twiml is growing and we're looking for an energetic and passionate community manager to help expand our programs. This full-time position can be remote, but if you happen to live in St. Louis, all the better. If you're interested, please reach out to me for additional details. I should mention that if you don't already get my newsletter, you are really missing out and should visit twimlai.com/newsletter to sign up. This week, we'll be featuring a series of shows recorded from Strangeloop, a great developer-focused conference that takes place every year right in my backyard. Not literally in my backyard, but here in St. Louis. The conference is a multi-disciplinary melting pot of developers and thinkers across a variety of fields, and we're happy to be able to bring a bit of it to those of you who couldn't make it in person. Later this week, you'll hear from Sumit Shintala, a research engineer at Facebook AI Research Lab, Matt Taylor, open source community manager at Numenta, Allison Parrish, professor in the Interactive Telecommunications program at NYU, and Sam Ritchie, software engineer at Stripe. We'd like to send a huge shout out to Nexosis, who helped make this series possible. Nexosis is a company focused on making machine learning more easily accessible to enterprise developers. In fact, you'll learn a bunch more about the company and what they're up to in this show, which features my interview with Nexosis founders Ryan Sevey and Jason Montgomery. Ryan, Jason, and I discuss how they got their start by applying ML to identifying cheaters in video games, the application of machine learning for time series data analysis, and of course, the Nexosis Machine Learning API. If you like what you hear, they invite you to get your free Nexosis API key and discover what they can bring to your next project. You can do that at nexosis.com/twiml. That's nexosis.com/twiml. And now, on to the show. Hey everyone, I am on the line with Ryan Sevey and Jason Montgomery. Ryan is the CEO and a co-founder of Nexosis, and Jason is the CTO and also a co-founder. Welcome to This Week in Machine Learning and AI, guys.
Thanks for having us.
Yeah, awesome to be here. Thanks so much for hosting us.
Fantastic. So as is the tradition here on the show, why don't we get started by having each of you introduce yourselves and tell us a little bit about your journey to machine learning and AI.
Yeah, sure. So happy to. As you mentioned, I'm the CEO and co-founder of Nexosis. Jason here is our CTO. And kind of just going back to maybe the beginning of how all this came to be. Jason and I actually met each other at a company called American Electric Power, which is headquartered here in Columbus, Ohio. Him and I were both on the cybersecurity engineering team. And AP, I believe, is the largest generator of electricity in the United States. So when you think about that, you can think about all the different assets that they have deployed in the field, which kind of directly correlates to how much data is being collected. And basically our task there was to ensure that all their assets were secure from both internal and external attackers. We quickly realized that the amount of data that was being generated would be pretty much impossible for the analyst team to go through and identify any kind of anomalies, things of that nature. So Jason and I then started thinking and hearing more about machine learning, and there were classes offered online, I believe, through Stanford University. And him and I both signed up to do these online courses, and we went and did all the homework, did all the, kind of bonus material, if you will. And we got to a point where the instructor said, okay, you now know more than everyone in the Valley. And we're like, all right, that's a good stopping point. So it was becoming very mathematical, and that's not necessarily a bad thing, but, we are both very technical individuals, lots of development experience, things of that in our background. And just quite frankly, like learning 6 layers of mathematics isn't that appealing. That's not, cool. I guess it's neat to understand the math behind this one algorithm, but quite frankly, that wasn't why we were taking it, right? We were taking a class to really understand how we could use machine learning to solve a very particular problem. So out of that, we just kind of long story short, Jason ended up leaving American Electric Power. He went to Veracode. He was a principal .NET researcher for them. Veracode is an information security company that does software. Well, why don't you tell them about Veracode?
Yeah, we do binary static analysis. You submit your binaries, and we find flaws in the code and give you sort of a report that says you need to fix code in these places or whatnot. So I was a researcher there for about 3 years.
The reason we bring that up is when he left AEP to go to Veracode, I shortly thereafter left AEP to go to Hewlett Packard. But Jason and I kept doing joint research projects together, just mostly out of fun, right, in our spare free time. So that means that we lost access to all the AEP data, that's fine. And we were kind of still enthralled with this notion of what machine learning could do, and we started thinking about other use cases. And I forget exactly how it happened, but I asked Jason one day why he didn't enjoy online gaming, and his response was basically, there's a lot of cheaters in it, and I want to know if I'm getting, owned or dominated by someone in the video game, that it's because they're actually better than me, not because they're using cheats. So I thought, well, that's kind of an interesting feedback. I said, I wonder if we could use machine learning to identify patterns in, public data sets available via the Steam API that would identify a cheater. And I think really the whole notion back then was if you're cheating, you're trying to do something that a normal human wouldn't do. Right. So it should show up in the stats, right? Like if you see this a ridiculously high headshot percentage, you're probably cheating unless you're a professional, right? Or if the stats show for the last 2 years, you have an accuracy rating of 15%, and then suddenly overnight your accuracy jumps to 50%, well, that's suspicious, right? So Steam makes it pretty easy to get all that data that we needed via their API. So we spent about 6 months and we created a proof of concept that basically had a pretty good accuracy rating. It was 88% accurate on identifying whether or not a player should be banned by Valve anti-cheat.
Well, if I can interrupt and ask a question or a couple of questions. I'm assuming then that you were using supervised learning for this task. And if that's the case, what did you use for labels? Did you manually label some number of users that you thought were cheaters? And then how did you validate this to determine your 88% accuracy rate? Did Steam also publish whether they thought folks were cheating, or did you just look and see if they were eventually banned or something like that?
Yeah, it's a good question. So what we did was we took the Professional Gaming League websites, we took data from there, and our theory behind using them to train not cheaters was that people tend to be watching the professional gamers more. There's more eyes on them. So cheating would be more obvious. And then we went to there was a website called VacBanned. Its whole purpose was to take Steam IDs and categorize those that got banned based on certain dates. We were able to correlate those with the Steam API and pull down their game stats. We did some cleaning of the data. We looked at when they purchased CSGO, if they had the game, because the data set wasn't perfect, like all data has lots of crap in it, but we spent a lot of time sort of analyzing it and making sure we had a pretty confident set of cheaters and a pretty confident set of those we felt weren't cheating. And that was sort of the process we went.
Awesome. And so what'd you do with this proof of concept?
Yeah, so at this point in time, we released the research to the public at a security conference called DerbyCon in, I think, 2014. And there were some Reddit posts, and it got a lot of traction. Actually, Valve reached out to me about the research and kind of was asking how we did it and whatnot. And I told them, because at the time I was like, well, fix the issue. That'd be more than enough for us.
Yeah.
So that kind of naturally led to the formation of Nexosis, because as we were going through the model building, we tried using different services like Microsoft's ML Studio.
Okay.
We tried using Amazon's API for machine learning. We tried using Google's Predict API. And at the time, Datto was still a company which became Tori, which then sold to Apple. So we tried all these different things on the market. And the conclusion that we reached from all this was nothing's really out there for the developer. Everything is really catered and aimed at the data scientists. You still have to understand how to train and build a model. And, then you just get into this question of how do I make the model better? And like fundamentally, you have to know the algorithm you want to use, and you have to know why you would want to use algorithm A over algorithm B. So there's just lots of issues that from a developer point of view, i.e. we want to just get something out there that's doing a good job, a very, very painful experience. So we then set out with that knowledge intact, and we said, look, why don't we look at machine learning under the lens of a developer? And how would a developer want to consume machine learning? And this has been done in other industries for a while, right? So the one that I can point to just off the top of my head is Twilio. And you think about what Twilio did, kind of very similar when you look at the data science machine learning landscape. Prior to Twilio, if you wanted to create a communications application, you would have to really have someone on staff that understood the telco infrastructure, understood voice over IP protocols and how to configure it. We actually have a slide here internally that kind of compares, here's what the world looked like before Twilio, and here's what it looked like after. I think the world today looks very similar in a data science point of view, right? You would have to know all the different, just how do you do ETL? How do you deal with missing variables? There's just so much to it. And then again, how do you know what algorithm you want to use and when and blah, 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 right? It becomes very, very complicated. So the whole notion with Nexosis is saying, look, developers, you use the same language that you're used to using. If you're a .NET developer, come to us, use .NET, C#. If you're a Java developer, then go use Java. You don't have to learn a new language to incorporate machine learning into your project. And that's really the whole basis of Nexosis.
Okay. When I think about let's take Azure ML for instance, when I think about what they're trying to do, it sounds exactly like what you're describing, right? They're trying to create an API that lets a developer deliver, machine learning types of applications. They've got the studio. You can even do it drag and drop if you're so interested. If you're interested in doing so, maybe we can dig a little deeper, and you can, when you're faced with skeptics that say, how can you enable a developer to do machine learning without knowing anything about data science? Like, how do you address that?
It's a good question. When we looked at ML Studio, for instance, a lot of the work, as you know, is data preparation, data cleaning, ETL. It's like 80% of the work. And then there's scaling. There's how do you do imputation strategies? How do you aggregate data? All these sort of questions. And developers are very used to working with data and data types. And you can typically take a data type, identify it, and you kind of know what step you need to do to impute or aggregate at that point. And so giving the developer the tools in their hands to sort of define maybe the data types with metadata, but not really having to worry about what needs to happen before it can go into the algorithm, before we convert it all into numbers, whether we need to one-hot encode categorical data, things like that. How do we pick features? All of that stuff there's a lot of automation that can be done to simplify that. Now, you still have to know your data. You have to know a good question you want to ask. You have to validate that, you are submitting features that make sense. We're not going to know your data for you, but in a lot of ways, we can automate some of that heavy lifting at scale. And then we can build lots and lots of models looking at different combinations of those things and then sort of finding what falls out of that.
And just to add to it, the other thing with all the different platforms is that you would still have to know how to go in and manually tune the models to make them better, right? So if you're in Azure Studio and, you pick an algorithm, which I think is the first hurdle, right? So you're a developer, you're in Azure, and now you have 15 different algorithms underneath regression. So
Right.
which one are you going to pick, right? Like you're a developer, you're sitting there, you're seeing 15 algorithms. How do you know which one to use? And how do you then go about making that model better, right? Via tuning, or maybe you have new features. With Nexosis, we do all that for you. So we have probably close to like 150 different algorithms at this point that are in the platform. And basically, just kind of high level how it works is we hold these tournaments, and the algorithm that's performing the best based on scoring metrics is the one that's used. So you as a developer don't even have to come to us and say, hey, I know, like, I'm going to use boosted decision trees. You don't even have to know that. You just have to say, hey, here's the problem that I have. Here's what I want to solve for. You guys build all the models, and then you guys tell me the one that's doing the best.
Right. There's sort of like a universal pipeline we use depending on the type of that problem you want to solve. And it sort of makes a lot of those decisions based on metadata that they provide as well.
Are there specific types of problems that this works for? It sounds a little bit too good to be true to be kind of applicable to everything or anything. Like I can give it any kind of data and it could do any kind of algorithm.
Yeah, so right now we're not going super deep into what is traditionally viewed as the deep learning space. We think that's pretty well solved, right? Like if you want to go predict, is this a hot dog or not? Like there's plenty of things out there that will do that for you already.
Silicon Valley reference.
Right. And like, so we're not really super focused on deep learning. We are starting to incorporate more things around voice and speech. So NLP, and not exactly sure how deep we'll end up going in that vein. But we're really more focused on the true machine learning and kind of the layer that's above deep learning. So, we're not going to probably release anytime soon kind of like an image recognition element into our API. Again, I think that's been solved, and it's been solved pretty well. But where you don't see a lot of stuff is underneath like regression and classification and clustering, and again, kind of all the real machine learning types of elements. So today we launched the API doing time series, which I think is also a little bit unique. You don't see many platforms out there that have true time series capabilities in it. I think time series is just naturally kind of a very hard thing to create models in and really apply machine learning to them. So we launch with any kind of time series problem. So today, if you have a time series type question like demand forecasting API, we do that. We just released regression, so any type of regression problem can be solved with the API. And later this quarter, we'll be releasing the classification endpoint. And then we'll just continue going down that vein of machine learning, if that makes sense.
Okay. Now it sounds like, when I think about the tournaments that you described as kind of conceptually happening on the back end, it strikes me that for a given problem, let's say I've got a bunch of time series data and I am trying to do a predictive maintenance type of application. Is that the kind of thing that you might do?
Yeah, that's one of it. Most just because of where we were, and when we did the Techstars Retail Accelerator, a lot of the early use cases with the API are more about, hey, I have this store, it's in Columbus, Ohio, and I need to know of the 100,000 products that I have, how many I need to have on the shelf for next week, right? So when I place my reorder, how many new products do I need to have in my warehouse? So more that demand forecasting type of element. But yeah, predictive maintenance would work as well.
Okay. And so the time series in that latter case is, in the retail case, is transaction history?
Right. Yep.
Okay. In either of these cases, like I'm thinking about you've got some set of models then that you are training that you're training against this data. So there's kind of a fan out there, and then for each of these models, you've also got to, do the hyperparameter tuning and all that. So there's a fan out there. It strikes me that I guess I'm trying to put my hands on like the scale aspects of the problem. It seems like for any given individual problem, you end up doing a ton of different training runs. And I'm wondering, if there's some way you can kind of characterize or help me understand the way that looks from an underlying resource perspective.
Yeah, we have a very dynamic workflow engine that it's queue driven, so we can scale in and out of number of CPUs we want to use. So it scales up and down automatically based on demand. So we spent a lot of time building automation to sort of handle that. So we're not, we have the cloud to work with, so we can do scale sets, we can do a lot of different things in parallel.
Mm-hmm.
So, we could build 100 or 1,000 models all simultaneously and compare different results, try different hyperparameters, try different feature combinations and things like that. And then once we get sort of down to a solution that works well, that they're happy with, they can sort of tune more parameters around that or go with that model and use it to predict.
Okay. Is there any particular method that you're using to do the hyperparameter optimization?
I would have to ask our data science team to get in the details of that. We do not have PhDs and 10 years of experience in the industry. While we do have some understanding of machine learning, we thought it important to hire a research team to solve some of the more complicated issues that we're not qualified to solve.
Yeah, so when Jay says we, he means him and I.
Yes.
But we do have PhDs at Nexosis.
Yes, we do.
Right.
Yeah.
Got it. And so when we talk about the kind of the time series, I guess it kind of makes sense that that was a initial place to start, and that was a little bit of the kind of data problem that you ran into at the power company. Is that right?
Yep.
Can you talk at all to kind of the unique, any of the unique challenges or things that you do with regards to time series?
One thing that I don't think people think about is using the product SKU example that we were discussing earlier. If you have 100,000 SKUs, that means ideally you have 100,000 models, right? So every SKU has its own model. And the real power of what we're doing is that each individual SKU could have a completely different type of algorithm winning, right? So if you're selling snow shovels as one SKU item, a different type of fundamental algorithm might be winning based on location too, right? So if you have a store in Columbus, Ohio, then you have a store in, like Atlanta, Georgia, very, very different results, even though that's theoretically the exact same item, right? So that's really the other power, is that we're able to take into account, okay, you're selling a snow shovel in Columbus, Ohio, and it's probably going to be snowier here, so you're going to sell a lot more.
Right.
And again, just a different algorithm might be winning here in Columbus, even though it's the same exact item. And then just thinking that even farther out, when you think about things like bottled water as an example, an algorithm that's going to predict how much water you're going to sell might look a lot different than an algorithm that's going to predict, how many white T-shirts you're going to sell, right? The feature importance in both of those might be dramatically different. And I can tell you they are different, right? So that's the other thing. When you start thinking about scale, one model or one algorithm doesn't fit all, right?
Mm-hmm. And so you're able to so if as a developer, and let's maybe dig into this retail case. As a developer, how am I giving you my data? I'm assuming that's the starting place.
Yeah. So what we do is we have a couple different ways you can import data through the API right now, and it's through JSON or CSV. And then we have some S3 endpoints where you can put larger data sets, and then we'll ingest them from there.
Okay. And so I'm giving you this data via the API, and how am I doing anything then to kind of describe this data, or are you figuring it all out somehow?
So we try to have what we call sane defaults. So if you didn't give us any metadata and you uploaded a data set, we would do some basic analysis of that data set and try to create appropriate data types for each one. Now, is that going to work great? Probably not, but will it work well enough to sort of get some results? That's our hope. And then as people sort of learn more about what they need to do with the data, we have metadata that you can use to sort of describe, this is a string, this is categorical data, or I need an imputation strategy on this numeric field that does mean mode, or that sort of thing. So you can start to describe, and we'll try to make some of those decisions for you, but it's better certainly once the developer gets in and sort of gets their hands around their own data and understand what they need to do with it.
Okay. And you've mentioned imputation strategy a couple of times. Tell us what that means.
The idea there is, if you want to look at aggregating data over time, the question is around, do you add it up? Do you sum it, or do you take an average, right? If you're looking at the weather, adding up temperatures doesn't make any sense, right? You want to average that over time.
Right.
So it's that general idea there that you can sort of indicate what type of data it is, and then we'll take that step of how you want to handle that aggregation or imputation around that. So if fields are missing, right, we might put in something else. Or if you want to roll up your daily or hourly forecasts up to a monthly forecast, we're going to use different strategies to sort of roll that data up as well as fill in empty values.
Mm-hmm. So I give you this time series of transactional data for this retail use case that has date, time, SKU, purchase price, and maybe some other stuff. Like, how do I tell you what problem I'm trying to solve?
You're basically going to tell us the column that you're wanting to predict off of, right?
Yep. So in that same metadata, you just say these are features and this is a target. And you can turn those on and off for each run as well. So if you want to turn off a feature, you could then predict on a column. You could turn it back on. You could do what if scenarios that way too, to sort of say, what if we did this or that with those features too?
Mm-hmm. And then are you able to do anything with around like artificial features, like so features that aren't in the data in the, predicting home price example? You might want to look at the number of rooms times the number of bathrooms, and that, particular kind of artificial feature might have some predictive value, that either of those features by themselves doesn't have.
I mean, it depends. I would say in those cases, no, we're not going to just sort of brute force through all your columns and try multiplying them and see if something happens or dividing by something. You know what I mean? Like, that's a hard problem. So I think in that sense, you need to know a little bit of your data and what the indicators are. But in other cases, we can sort of do some interesting things with maybe holiday calendars we can automatically overlay with your time series data. We've done some work sort of with, lat and longe locations. We can incorporate weather automatically, certain weather features that might help. So it depends on what it is. And we have some interesting ideas and plans in the future for that as well. But no, I mean, at some point you have to sort of understand what the indicators are that may help you predict, right? Like we're not a crystal ball.
Mm-hmm. So I tell you what columns I want to predict on. And how does you mentioned earlier that the platform will, build individual models for each of the SKUs. Is that something that I need to tell it to do, or is it always doing that?
It always does that with a caveat. Once you have a model built, you can reuse it. The problem with time series data is often yesterday is a better predictor of today or tomorrow than a week ago. So there's sort of the notion of how long my algorithm is good for, right? And so on the time series, you end up rebuilding models a lot more frequently than you might with like a regression model. That's just, not as concerned about those sort of yesterday as the future or 2 days ago, 3 days ago, last week.
Okay. Maybe tell me a little bit about some of the kind of technical challenges that you had to overcome to put all this together.
Boy, yeah, that's a big question. Where to start?
That could be a second podcast.
Yeah, I think really, when you try to build a generalized platform, there's so many challenges, around handling all sorts of data. And we can't boil the ocean, so we have to make a lot of trade-offs and choices around what is the MVP going to look like? What is the next version going to look like? What can wait? What do we have to have now? How do we get something to market? And so from the product side, it's been a big challenge to sort of make those trade-offs and then get the work done in a way that we feel good about the results. So I think building sort of that ETL pipeline in a general sense, sort of that pipeline around, do you scale the data before you run the algorithms? When do you have to do that? And sort of building in sort of all that core capability around how do we get any sort of data into a common sort of matrix to do ML on? And there's lots of different paths to get there. And I think one of the big challenges was trying to define the best use cases for us to sort of get the broadest hit. Now, we have to trade off some accuracy for that, and that's okay. As we go on, I think we feel like we can get better and go deeper in a lot of areas.
Mm-hmm. Yeah, that was a question that I had earlier, and I didn't ask it. Often when I've talked to folks working on generalized machine learning platforms. The idea tends to be, you're trying to get the developer, the organization from, 0 to 80%. And then maybe once they're, at 80%, have some maturity, they may find that they need to invest further to get to, 90x%. Is that the general way you think about the problem as well?
Yeah, to a certain degree. It's always, I just think where we are today, getting people familiar with what machine learning can do is kind of the first hurdle. And then, as you were saying, how do we get better performance after we actually have something in the environment or some kind of application deployed that's using machine learning? So I think there's this natural evolution. And that's one of the things that we've kind of built into our own platform is, let's talk about like a regression problem. You were talking about house prices, I think, earlier. Well, let's say your initial data set has like 15 features and it's like room size and how many bedrooms and whatever, right? And you build your model and it's pretty good. But then as time goes on, you might think, well, hey, you know what? Maybe this new thing that I just thought about is going to have a big impact. And maybe that new thing in this scenario is the school rating in your area. So now you're going to bring in the whole new feature of school ratings for the house that you're looking at. And then with us, it's just naturally going to build a new model. So you don't even have to think about, all right, well, now I have this new feature. Do I need a new algorithm or not? If you do need a new algorithm, our platform's just going to figure that out. And it's going to say, all right, well, maybe you're using like Classio regression or something before. Now you're going to use, I don't know, whatever else because you added all these new features. I think that's really the other big power of this, right? And as people start looking at the accuracy and the results, I think the natural question is always going to be, well, how can we do better, right? And we are trying to spend a lot of time and energy on that educational component, which is kind of answering that question of, okay, we have this today, how do we get it better, right? Is it going to get better if we add in school ratings? Maybe, probably, but let's figure out what happens when we actually do it. And then they'll figure out, okay, well, this had no impact or it had a big impact. And then that should lead to the next question of, all right, well, what else could we add maybe to make it even better, right? And you could just keep going down that whole trend and naturally just our platform is going to figure out, okay, as you mature and add new features, we're going to pick maybe a new algorithm that's going to perform even better.
Yeah, it's funny. A lot of those things, those activities that you're describing on the spectrum of, improving your algorithms are things that I think of as data science. Like if you separate out the knowledge of the underlying math from, the process and the way of thinking about, data and features that have some predictive value and using those to create predictions. Like that, to me, a lot of that is what a data science is really about. And I'm wondering if is it that you end up teaching developers, those parts of data science in order to get them productive on this platform? Or are you finding that there are, maybe folks with different roles that understand that stuff but don't understand the math? How do you kind of see the audience and for what you're doing and is it evolving at all?
I think the audience is absolutely evolving. I think as we look at the future, we're releasing some additional features that should really marry this notion of developers teaming up with data scientists. We want to enable more collaboration in that space. We think one of the main things as we look at more mature organizations is shortening the time from R&D to production. So if you're a data scientist and now you're collaborating real time over, this maybe beta application that a developer has made, that kind of really speeds things up. And then as the data scientist is looking at what the developer maybe made as an initial proof of concept, yes, that data scientist then might really be honed in on, okay, how do we make this better? So that's one approach. And then I think, again, you just have so many, from an innovation perspective, enabling developers to quickly prototype things has a tremendous value, right? And then just being able to show if you're a developer, maybe you have a data science friend or someone at your company is a data scientist, being able to say, hey, look, I made this prototype application and it's doing X. what do you think? What else maybe could I do to it, right? So just fostering that collaboration is obviously really important to us as we look at, especially 2018, you should see more and more things start to be released.
Just to add on to that, there's really not enough of data scientists to go around, unfortunately. So we also enabling, I think, people to get some capability up is better than, them just having to go hungry, so to speak.
Yeah, yeah. Are you doing anything where it's industry or vertical focused where you're able to, you've got data scientists that are thinking about the problems in those verticals and what the data needs to look like and what the features are so that you can, guide or offer special, features for specific verticals, or is that not a focus for you right now?
Yeah, so shortly we should be releasing this notion of kind of data templates. The idea behind that is, at a bare minimum, here are kind of the features that you would need in order to be successful with this type of problem, right? So SKU level forecasting, as an example. The bare minimum features would be length of time, right? So ideally you want a year of data. It can work with less than that, but best performance is a year. And then you're going to want, probably daily sales activity. And then beyond that, those are just the bare minimum. You can create a forecast off just those two things because the platform will automatically extrapolate out based on the timestamp, if it's Monday, Tuesday, Wednesday, and it will find the weekly and daily trends, things of that nature. But then you could start adding into that template additional things that maybe aren't necessarily required, but they're nice to have, right? So a nice to have would be, do you have a promotion going on for that particular item, right? And that could be a binary 1 or 0. You could extrapolate out what kind of promotion it was, right? Is it like a buy one, get one? Is it just a % off? Things of that nature. But yeah, we have plans to kind of put out there, here's a bare minimum that you need, and here's kind of the nice to haves, and kind of go from there.
Oh, interesting. So in that example where you've got a developer, they've gone out and collected some sales and marketing, historical data, and they're doing a forecast. How do you articulate to this developer that may not be, statistically sophisticated, the extent to which they should rely on this result that your platform spits out for them?
Yeah, currently we put out some metrics on that. And what we've determined is we need to get a little more friendlier on those metrics. So we have some sort of education around what the metrics mean and sort of some of our learning on our documentation site. But we want to really go to the next level, I feel like, and really sort of hold their hand a little more on what the metric is saying about the model based on what the data they have.
So currently, I think we return MAPE scores if it's a time series type forecast. And yeah, we plan to make it even more friendly than that, right? Because the developer might not understand what MAPE is. MAPE, mean absolute percentage error.
Okay. So it sounds like this is like these interfaces between kind of what you might expect the data scientist to know and what the developer might not know, or some of the key challenges that you face as you evolve this and bring more people onto the platform.
Yeah, honestly, I think that's just quite frankly, I think that's a minor challenge. I think the biggest challenge that we have, and I think just the industry has in general, is access to data. If I want to build, and honestly, I was thinking about this over the weekend, I wanted to build a couple of different applications, and the hurdle is getting the data sets, right? So if I wanted to build an application off of, predicting cancer, there's certain cancer data sets already out there. There's a very famous, the breast cancer data set that kind of has the size of the tumor and things of that nature. But maybe a big important feature there is where the people live, right? If you live next to, I don't know, a waste site, that's a little bit extreme, but let's say that you live there. Maybe that's why you have cancer, right? So maybe where people live might actually be a huge indicator whether or not you're going to develop cancer, or that lump that you discovered is benign or malignant, right? But it's very hard to get that data set, right? Number one, you have the HIPAA issue, so there's that little hurdle to get over. But then more than that, it's just, are people going to want to share the data? The other idea I had was predicting whether or not a startup would be successful. And one of the things that I think you would need to do that would be kind of the financial information on the startup, right? And how much money they're spending where and the return. But again, trying to get reliable data that's going to help me build that model is kind of what I think right now is the biggest obstacle in the field.
Any other thoughts on that particular point? Any other obstacles that you see?
Yeah, I mean, there's plenty of them. I think really walking them through what their data might be telling them is going to be helpful. So like one of the big challenges is, you submit a data set, and I think there needs to be more of an indicator of you really can't do anything with this potentially in some situations. In others, it's like, it's okay. And then like, this is really good data. So I think sort of kind of defining and helping them along without just raw metrics, like give them a little more, I guess, safety feeling about their models is still a challenge. And then we have a lot of ideas around that.
Yeah, I think just also to add to that, one of the challenges is just how machine learning, AI, whatever you want to call it today, has been talked about in the media.
Oh, yeah.
It's put into the minds of a lot of people that machine learning is this magic bullet. And to give kind of a real example, we have some people today that have signed up for the API that want to use it to predict things like Bitcoin price. And their data set is just the price point on a day. And they think that machine learning is just going to like magically figure out what the price is going to be. And, sometimes we have to talk to the people who sign up on that use case. And we're like, well, if that's all the features you have, do you really think that Tuesday is the reason why Bitcoin jumped up? Or do you think there's this other feature out there that is really impacting and influencing it, right? So again, it's just people really have to, I think, get beyond that. Machine learning isn't a magical bullet. It's only going to find the patterns in the correlation in your data set. If it's not there in the data, it's never going to find the pattern.
Yeah, that's awesome. So anything else that you'd like to share with the audience as we come to a close?
Just the only thing that I was thinking about is as we were talking about kind of our overall goal, and I think really most of 2018 is going to be this theme of how do we enhance collaboration between developers and data scientists. One of the newer features that we'll be releasing in 2018 is something called Bring Your Own Algorithm. So what this is going to do is it will allow a data scientist to create maybe a very specific algorithm that is really good at solving for a particular thing. So let me give an example. Let's say that you are a data scientist at like Best Buy or some big box retailer. And let's say the retailer really cares about the price or the sales for LED TVs. Well, the notion is that they might create a very specific algorithm that's really good at figuring out, hey, how many flat screen LED 55-inch TVs are we going to sell? And all that they would have to do is take that algorithm that they build in-house, they could just plop it into our API, and their algorithm will live just in their instance. It'll live by itself. Well, it'll live just in their instance by itself, but it will live side by side our 150 plus algorithms. So they'll be able to see in real time, hey, here's where our algorithm is winning and here's where it's not winning.
I guess a related question that I had from earlier, as you're starting to get into collaboration and data scientists working with developers and developers exploring their data and creating new features and things like that, it opens up this whole set of issues around model management and model governance and model provenance and stuff like that. Are you, as a company, thinking about any of those things, or do you offer support for those kinds of challenges?
Yeah, that's certainly come up in the past. We've had it come up primarily in the insurance industry.
Yeah.
The regulations around the model building, you really have to understand how the decision is coming about, right? Because you can't discriminate and things of that nature. So yeah, for kind of the more enterprise customers, we'll allow them to actually download that model and algorithm and kind of have that supporting documentation they need to have to prove that, we're not using, for lack of a better word, illegal types of data sets to create, the prediction result. So I think as time goes on, we're going to see more and more of that. And again, right now, one way that we can solve it is just by giving a Dockerized container that contains the algorithm and explain how it works and things of that nature. So yeah, I mean, as time goes on, I think we're going to see more and more of that.
Okay. All right, great. And then did you have an offer for like free access to the platform or a free API key or something like that available to listeners?
Yeah. So anyone can sign up for the API for free. That's part of our philosophy as a company, and being developer first is that we want people to use it. So we do have a community edition. It's 100% for free. It will always be free, that community tier. So yeah, anyone can go to nexosis.com, sign up for an API key, and get started in under 5 minutes.
Okay, awesome. Well, guys, thank you so much for taking the time to chat with us. I think what you're doing is really interesting, and I will certainly be looking forward to keeping up with you. And I'd love for you to keep in touch and, let me know about, as the platform evolves, your continued success, et cetera.
Yeah, definitely. It was a pleasure being on here, and thanks so much for having us.
Okay, so before we go, why don't you take a second and tell me a little bit about what's the traction been to date? How many users do you have, or how many companies are using it?
Yeah, so currently we released the API to the public on July 11, 2017. To date, we have over 4,000 developers that have signed up, and we have close to 500 applications that have been deployed.
Oh, wow. All right. Well, once again, thank you so much for taking the time to chat with me. I appreciate it.
Yeah, likewise. Pleasure. It was fun.
Yeah, thank you.
Awesome. Thanks, guys. All right, everyone. That's our show for today. Thanks so much for listening and for your continued feedback and support. For more information on Ryan, Jason, or any of the topics covered in this episode, head on over to twimlai.com/talk/69. This interview kicks off our Strange Loop 2017 series. To follow along with the series, visit twimlai.com/stloop. Of course, you can send along your feedback and questions via Twitter to @twimlai or @samcharrington, or leave a comment right on the show notes page. Thanks once again to Nexosis for their sponsorship of the show and this series. For more info on them and to get your free API key, visit nexosis.com/twiml. And of course, thanks once again to you for listening, and catch you next time.